Hey, welcome back to video number 48, editing a header file in ENVI. In the last video, I showed you how to take level 1 radar data and process it using the MapReady software from Alaska Satellite Facility. And the images that we're processing are actually JERS-1 radar data from the Middlebury area that we're going to use to map wetlands in the Middlebury area. Now, chances are your images have not finished processing. Don't worry about that for now. I'm going to make available to you the images that I processed. So don't worry if your images haven't finished processing yet. But what you'll find is that when your images do finish processing, they are fully rectified and they're projected in a UTM coordinate system, but they don't have a header file, okay? They don't have a file associated with them that's going to tell ENVI or ArcMap what projection they're actually in. So in this video, what I want to do is first tell you what is a header file, and then I want to show you how to edit and create a header file in ENVI. So as I just said, the header file is a file that's usually associated with a GeoTIFF. It's an additional file that stores metadata, information about how big the pixels are and what the spatial reference system is. So the easiest way to explain this is to actually go find a header file. So here's a folder. Here is my header file. It's got the .hdr extension, and you can see that's associated with a TIFF file of the same root name. So here's the TIFF file where the actual data is. Here's the header file that has the metadata. Now this is just a text file, so I'll right click and I'll go to Open with WordPad. And you can see it's just a text file. It's an ENVI header. It's got some description, number of rows, columns, bands, data type. Down here there's some really important map information. It's a UTM projection, and the pixel 00, which is the top left pixel, has coordinates of this northing and this westing. So that's how ENVI knows where to start reading in the coordinate system, to place the top left corner at this coordinates. Likewise, the pixel size is 12.5 meters by 12.5 meters. So it knows how many meters to add on for each pixel. And it's a UTM zone 18 north WGS 84 datum. So there's all kinds of useful info in here. The problem is when our maps were processed in MapReady, it did not write a header file. So we're going to need to do that ourselves in ENVI. Okay, so I've got ENVI open. The first thing I'm going to do is go ahead and open one of my data files. Now you're going to find these files in Lab 9 Data under Will's Extra Files. Now these are the two files that I just finished processing, and you'll notice that they each have a TIFF and a .metadata file. Okay, so let's go ahead and open these two TIFF images. I'm going to hold Control, highlight them both, hit Open. It's going to take a second for them to load and for the pyramids to build. Okay, so my two images have been added and they're being displayed by ENVI. But importantly, ENVI can display them just as an image, but it does not have any spatial reference information. So the first thing to do is to correct that by getting the spatial reference information out of the metadata file. So to find the metadata file, I'll go back into the folder and I'll find the file with the .meta extension. I'll right-click, Open with Notepad, and this is another text file that has a whole bunch of relevant information. I won't go through it, but there's really a lot in here. The X and Y pixel size, and if you keep scaling down, eventually you'll find the projection information. So this tells you the type of projection, UTM. It tells you the coordinate of the top left, X, and the top left, Y, as well as the pixel size. So this is all the information we're going to need to actually create a header file in ENVI. So let's just leave this open for a second because we're going to need to come back to it to copy some numbers. Now, to actually define the header information, we're going to go into raster management, and we're going to go down to edit ENVI header. I'm going to choose my first image, the 26054. This is giving me some information about the image. So I'm going to click on Edit Attributes and go to Map Info. And now the Map Info dialog box is prompting me for information about a tie point. How can ENVI relate a given coordinates of a given pixel in the image to some actual geographic latitude and longitude coordinates? And so all the information you need to do this is going to be in the metadata. So to open the metadata file, I'm going to go back to the original folder and find the file with the extension .meta, and right-click, open with Notepad or some other text reader. Hit OK. And up pops the metadata file. There's all kinds of information in here. I'm going to scroll down to information about the projection of the file. This tells me it's in a UTM projection, and importantly, it gives me the easting and the northing of the top left pixel. It also gives me the pixel size and the datum or spheroid with which it's all referenced to, and of course the UTM zone. So I'm going to take all this information now and I'm going to fill it into this dialog box. Okay, so I've denoted that the image coordinate will be a 0, 0, x and y. That's the top left pixel. I clicked this button and changed the projection to be UTM zone 18 with a WGS84 datum. Then I copied in the easting and the northing of that top left pixel, and I set the pixel size to be 12.5. So I'll hit OK, and I'll hit OK again. And what's interesting is that ENVI actually took down that image from the display temporarily because it needed to stop displaying it so it could go back and actually reproject it. Likewise, if we go back to the original folder, what we should now find is an additional file. It has the same root name, but it has a .hdr extension. So we basically made a header file there. We gave ENVI the information it needed, and it wrote the header file for us. So now what I'd like you to do is repeat that process for the second image, 35939, and make sure that they're both loaded up here with their spatial reference information. Okay, so I've got both my images with spatial reference information. They have header files. I've got them both loaded up again. What I'm going to do now, I'm going to add one additional file, which is going to be a multi-band Landsat image. And that's going to be a Landsat thematic mapper image, which you can find here under the Landsat folder. Open the TIFF file, and this is a stacked raster. So if we look at it under Data Manager, we're going to see it actually has 7 bands. These correspond to bands 1 through 7 of the Landsat thematic mapper. If you'd like to look those up on Google, you're welcome to. Band 1 is roughly blue, band 2 is roughly green, band 3 is roughly red. And this image has also been clipped. I'm going to display an RGB color scheme and load that visualization. Then I'll apply an optimized linear stretch. Okay, so the extent of this Landsat image actually shows the extent of our study area. It's already been clipped. The next thing I want to do is actually zoom in on Lake Dunmore here, which is just east of Middlebury, and zoom into a sub-pixel level and actually see how well registered they are to one another. And I'm going to do that visually just by turning the layers on and off and watching how the coastline moves in the different images. What I'm finding is that the Landsat image and the 26054 image are actually quite well registered to one another, but that the 26054 and the 35939 are a little bit offset. Watch as I turn them on and off, and you'll see the coastline move a little bit north-south. So I'm going to make an ad hoc decision now that I would actually like to shift image 35939 north by about 2 pixel distances, and that I think that's going to make a better match with file 26054. And I want to take care of that before I classify the images. So to make that adjustment, I'm going to go ahead and edit the header again. I'm going to edit 35939, go back into map info, and I'm going to cheat a little bit. I'm going to say, instead of making that tie point at the top left corner, actually make it 2 pixels down from the top left corner. And that should have the net effect of shifting the whole image northward by 2 pixel distances. So I'll hit OK, and then I'll hit OK again. Once again, it's going to take that image down from the display, and then I'll have to add it again because it changed its projection along the way. So I'm going to toggle it on and off above the other image. Notice now the coastlines are much better rectified. We're not seeing that big north-south shift anymore. So at this point, we've registered these 3 images to each other within a few pixel distances. It's not a perfect registration, but it's good enough for our application today. And we're ready to move on to the next step. Join us for our next video, video number 49, when I'll show you how to actually filter these radar images to remove some of the speckle. Thanks.